Bapak Ibu sekalian. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Waalaikumsalam warahmatullahi
wabarakatuh.
Baik, selamat pagi dan salam sejahtera bagi Bapak Ibu sekalian. Alhamdulillah pada pagi hari ini kita bisa berkumpul kembali pada kegiatan Kuliah Umum Metabolomik kerjasama Forum Metabolomik Indonesia dan PT BRK Niaga Medika dan Agilent Technologies. Kami ucapkan terima kasih dan selamat datang kepada yang terhormat narasumber kita. Thank you and welcome to Mr. Thanong Phueaouan, LCMS Product Specialist Agilent Technologies. Dan juga terima kasih dan selamat datang kepada seluruh peserta Forum Metabolomik Indonesia, Bapak dan Ibu sekalian. Baik, untuk judul yang diangkat pada kuliah umum kali ini adalah mengenai Workflows for Metabolomics Profiling and Updating Application. Baik Bapak dan Ibu, untuk selanjutnya langsung diserahkan kepada moderator kita, Mas Fahmi, untuk memandu kegiatan ini. Silakan Mas Fahmi.
Ya, baik, terima kasih Ibu Laila. Sebelumnya, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Ya, selamat pagi saya ucapkan kepada Bapak Ibu hadirin yang alhamdulillah pada kesempatan ini bisa berkenan hadir dalam webinar kali ini. Tentunya saya sangat senang sekali ya dapat bergabung di sini, berada di sini hari ini bersama dengan semua rekan-rekan dosen ataupun mungkin di sini ada beberapa peneliti atau anggota dari Forum Metabolomik Indonesia dalam acara yang sangat istimewa ini tentunya. Oke, hai Thanong. Sorry, I will open with bahasa.
The problem shall I start?
Oke.
Yeah, thank you
Acara
so much.
hari ini, oke, thank you. Acara hari ini akan membahas topik yang sangat menarik tentunya dan sangat relevan, yaitu terkait metabolomics ya. Mungkin Bapak Ibu sudah ada yang familiar, mungkin ada juga beberapa yang masih penasaran terkait dunia metabolomics seperti apa begitu. Sebelumnya perkenalkan, saya Fahmi dari PT BRK Niaga Medika dan di sini saya akan memandu selama sesi pemaparan materi berlangsung. Nah, tentunya ketika kita berbicara metabolomik sendiri adalah salah satu cabang ilmu pengetahuan yang berkembang sangat pesat ya, dan memiliki dampak yang sangat luar biasa pada pemahaman kita tentang berbagai proses kimia yang terjadi di dalam tubuh manusia ataupun mungkin yang terjadi dalam hewan dan tumbuhan. Nah, pada hari ini kami sangat beruntung memiliki seorang pemateri yang sangat kompeten dan berpengalaman dalam dunia metabolomik yang nanti akan berbagi pengetahuannya dengan kita semua. Sebelum kita memulai, saya ingin mengingatkan kita semua untuk membuka pikiran dan hati kita siap untuk menyerap pengetahuan berharga yang akan disampaikan oleh pemateri kita pada kesempatan kali ini. Kami juga sangat mendorong partisipasi aktif dari Ibu Bapak semua, para peserta, dalam sesi Q&A yang akan diadakan setelah sesi presentasi. Jadi sesi presentasi ini akan berlangsung selama kurang lebih 1 jam. Kemudian untuk sisa waktunya 20 atau 15 menit nanti akan dilanjutkan dengan sesi Q&A. Nah, jadi nanti Bapak Ibu yang ingin bertanya, boleh silahkan untuk menuliskan pertanyaannya di kolom chat di bawah, atau mungkin nanti yang akan mengajukan pertanyaan langsung boleh mohon izin untuk untuk membuka open mic-nya ya, seperti itu. Nah, untuk mengefisienkan waktu, di sini pertama saya akan mengenalkan pemateri kita pada kesempatan kali ini. Name Thanong Phueaouan. I'm sorry for the spelling, Thanong. Beliau adalah LCMS Product Specialist dari Agilent Technologies. Thanong is an LCMS Product Specialist at Agilent Technologies. He began his career as a research scientist and worked for a GLP laboratory for 3 years. He joined Agilent Thailand in 2013 and has provided numerous customer training, application consulting, and technical support. He's knowledgeable about liquid phase chromatography, mass spectrometry, as well as its instrumentation and application, especially in life science and biopharma. Thanong obtained a master's degree in applied biological science from Chulaborn Graduate Institute. Thanong provide technical assistance to customer in Thailand, in Indochina. Mungkin itu sedikit perkenalan terkait pembicara kita pada kesempatan kali ini yang akan membahas berbagai aspek menarik dalam dunia metabolik. Hi Thanong, good morning.
Good morning.
Does my voice sound clear?
Yes, yes.
Okay. I am Fahmi from BNM as moderator this time. Thank you for attending this Metabolomic webinar.
Yep.
The presentation will run for 1 hour, then followed by 15 or 20 minutes Q&A session. It's okay?
Yep. Yes, yes,
Okay.
that's okay.
Okay, the floor is yours, Thanong.
Yep. Thank you for your kind introduction. Let me share my screen.
Okay, clean.
Okay. Do you see my screen?
Yes. Clear.
Okay. Thank you so much. My name is Thanong Phueaouan. I am LCMS product specialist that take care for Thailand and IDO country. Today, I would like to present about the workflow of Metabolomics, profiling and updating the applications. When we talking about omics, right now they have a lot of omics, right? Start from genomics, yep, proteomics, metabolomics, lipidomics, and fluxomics. We have a lot of omic application that a lot of customer, a lot of researcher, they focus today. And today, I will focus on metabolomics thing. When we talking about the challenge of multi-omics, you may know that they have a lot of the diversity of the compound, right? They have a large and complex number of analyzed from the metabolites that we need to quantify and identify. And we also have the challenge from metric complexity. Biological sample has complex metric. We need to have the good sample preparation to remove some of the metric, and it have a lot of the commodity group of the metric as well. That is challenge for method development. And the last one is wide dynamic range. Is this difficult to determine the very low concentration and high concentration at the same time? So we also need the instrument that can support for multi-omics application. So when we focus on metabolomics workflows, today I will cover from some example from the sample preparation, how to utilize the LCMS for metabolomic research, how to analyze the compounds using software and identify the compounds using the database. And finally, how to link between the compound with pathway mapping. Please take a look on the sample preparation first. I would like to say that there is no universal separation method to cover every metabolite in single MS run, because the biological food have a lot of the property. Some of them is nucleotides, amino acid, sugar, and lipid. Each of the sample needs spatial and appropriate sample preparation. For example, those compounds here will have the polar and hydrophilic property that we need to use the, for example, mixed mode or reverse phase to separate them and prepare them. And on the right-hand side, for the lipid metabolites, we also need to remove using another sample preparation. I provide some example here. If you handle some protein sample, we also need to precipitate them, right? We can use some captivars and SPE here to remove and precipitate the protein. We also need to remove the lipid that may affect to our metabolized analysis, right? For example, here we have some example about EMR lipid removal that can remove the lipid and still remain our metabolized. And we also have a lot of the solid phase extraction that you can choose appropriate to your analyzed, for example, C19, Prexa, and the basic one, liquid extraction, also useful for metabolomic research. The important one that I want to emphasize here is when we do the metabolomic research, we also need to have the quality control. The quality control come from the pool of the RQC of the sample. The pool QC here is really good to check about instrument as well as sample preparation. When you analyze the analysis the sample, you can plot the QC to check about the performance of the instrument as well as the sample preparation. And you can use the isotope labeling to check that your quality control is good or not. Next one, let's take a look on chromatographic separation technique. You can see here a lot of the compound, right, have their own property. Some compounds can volatile that you can use the gas phase chromatography, but if it's not volatile, you can choose the liquid chromatography. And they also have their own property about the polarity. Some compound really high hydrophilics that can be used for liquid phase chromatography. We'll be talking about chromatographic process. First of all, we need the column or stationary phase. The stationary phase here has the property to retain the compound of interest, and we will flow the mobile phase through the stationary phase. The compounds will be retained in different retention time. We can use the retention time for identify what compound when we compare to the standard, right? Some compound not retain is will elute very fast compared to another one. The result from chromatographics, you will get the chromatogram here. The x-axis will show about the reaction time, and the y-axis will show about the intensity. If we have the sample and elution in the same reaction time, we can show that this compound represent compound A. And we can use the area of the peak for quantitation approach. So please take a look on the video here. In this video, we would like to quantify the compound from the Agilent beverage. At the first stage, you can see here, all of compounds are mixed together in different color here. And when we put the sample to the HPLC, the HPLC will flow the mobile phase to the column here, and the injector will draw the sample as we command the method to pick up the green vial sample here to draw the sample and it's inject to the system. In this step, you can see that all the compound will mix together, not separate. Until it go to the column compartment here, the column will separate the compounds. It will reduce the complexity of the matrix as well. After that, all of the compound will go to the detector. In this case, we use UV detector to measure the absorbance of the compound. After that, we will quantify both reaction time and area to check about the labeling of the beverage. This one is the process of the HPLC. So when we're talking about chromatography, mass spectrometry, that means we combination between HPLC together with LCMS. When we combine two of them, that means it will increase the high selectivity and high sensitivity, because on the left-hand side for the HPLC, we separate compound using chemical property. We can have the X and Y, the two-dimensional data. And when we have the MS at the detector, the LCMS here will separate compound by mass. So we will have additional dimension here, so we can get the three-dimensional information of the data. And according of these results, the LCMS will provide you more information. When we take a look on the LCMS, start from the LC-Q-TOF system. LC-Q-TOF system suitable for the untarget analysis. For example, if you want to quantify your natural product sample, so you can use the LC-Q-TOF system. In another way, if you want to target your known metabolites, you need to choose the LCMS triple cross, because they have really good for quantitation compared to Q-TOF system. So when we want to identify the importance compound from the asthma study, first of all, we need to have the sampling, the sample, right, from maybe the blood sample, and then we need to do the sample preparation to do the protein precipitation, remove the lipid before we analyze using the LCMS system. After that, you can see that the Metabolomics data had a lot of the compound here. The software has really critical to support user to do the data analysis. The software will summarize and list of the compounds from the Metabolomics data. And after that, we can use statistical analysis to see the difference between control, treatment, and no treatment before we pick up the candidate compound to identification. And the identification takes a lot of time. For example, here, we can use the results to correlate between the asthma study and the compound that we want to see. So if we cannot identify, we cannot link between biological context as well. And the most time-consuming part is identification. So the data processing play a really important role here, because we need to have the software for feature finding. We need the alignment and statistical software, as well as the identification and pathway visualization. When we take a look on the peak extraction, you can see here the chromatographic. We had a lot of the peak. How do you make sure that how many compounds show here? The system will be show some example here. In this area, you may see that they had a few peaks, right? But using the software, it will go into detail and will find the compound for you. It will see the mass of the compound and summarize into the grouping of the compound. This one fully automated process that will support customer to easy data analysis. And for peak extraction, we need to set up the method for the data analysis as well. We need to choose the correct threshold to make sure that below the red line here should be noise. The upper should be the good quality data, and it will make sure that the peak areas at the highest quality. So we need the provider software here. The provider software here will use for batch filter extraction. The batch filter extraction is really nice in terms of when you do the statistical analysis, you need to inject many of injection. For example, if you have one biological sample, right? In the one biological sample, you need at least 3 or 5 injections to do the statistical. But in the real life, you need at least maybe 6 biological replicates. That means it will multiply by 3 or 5. So for one batch of your analysis, you may get 20 or 30 injection. How do you compare and how do you check that which compound show in every injection? If you have to manually process, it's really hard to do, right? So for the batch filter extraction here, it has the function to automatic align of the compound, right? You can see I inject around 20 injection here, and it will automatically show that the compound in number 30 we found in every injection, and it showed the peak chromatogram and sputum as well. This batch filter extraction is really useful because it will you can see the compound easily, not manually matched by yourself. So after we run the sample, we need the batch filter extraction to analyze the sample before we send to the statistical software. Here is the some example. When you run many of injection, right, you may have the issue about the chromatography is shift. Sometimes it's not at the same time. The software here will support you. If it's a bit reaction time shift out, it will automatically correction for you to make sure that all compounds are aligned in the same reaction time. Because the reaction time is so really important, right? The reaction time will represent the qualitative data. So this function of aligned chromatogram may be done before we do filter extraction. In the filter extraction here, it will link together. We can see the compound group in the on the left-hand side and compound detail and in below. We can overlay the sample replicate as well. If you have the, for example, the control, the treatment 1, treatment 2, and no treatment, right? We can show in the overlay in the black for the control, in the red for the treatment 1, for example. And all of the detail here can export everything to the statistical analysis, right? And in more detail, you can see that the batch filter extraction will have a lot of function to make sure that we can reduce the false positive, right? For example, the basic one is batch molecular filter extraction. That's when reduce the positive. And batch recursive filter extraction will reduce the false negative. So it's really convenient for customer to choose which mode that they want to do. After that, when we already extract the compound, right, we need to send to the statistical analysis. For example, here is MPP. The MPP is a chemometric platform that can do the PCA plot, volcano plot, Venn diagram, hierarchical analysis, and pathway architect. It's really convenient for the LCMS, GCMS, and ICP-MS as well. So if you have your laboratory that already have the GCMS and LCMS, right, the MPP can process both of them. I will provide some workflow. For example, here, if we have the LCMS system or GCMS system, both of them can send to the provider to do batch filter extraction before send to MPP and identify the compound using the browser before we shoot the candidate compound to analysis for the pathway architects. So here is the workflow that really important for metabolomics research. Please take a look on MPP. MPP here has a lot of functions that you can choose from the navigator, from the experimental, as well as the result in the center here.
Itu yang bawah diulangi ya.
Mohon maaf Ibu, mungkin bisa di mute dulu. Ya, continue. Thanong next.
Thank you. And on the right-hand side, we show the workflow browser, right? In the workflow browser here, we can choose different statistical analyses. This one is in detail, right? When you try to using the MPP system, the MPP system will have the terminology we can create from the project, right? In the go to the detail about experimental, that we can set up the parameter, condition, and how to interpret the results, as well as show the entity or feature as well. And on the right-hand side, the MPP software have inspector. The inspector here will be inspect all of the results. So that's would like to share you about terminology of MPP. When you start the MPP analysis, for example, here I start malaria study. In malaria study, I click the create and use the compact group. I can put the sample of the malaria sample, right? I can set up the parameter here to compare between different conditions between treated and control. After I create the workflow, I can use the significant analysis workflow. That is we have the function of wizard function. The wizard function here will guide customer to go to step by step. That's really easy to start from import the data, how to do normalized, how to create interpretation before we do significant testing. So the MPP system, the MPP software can do a lot of things that we can shoot. We can start from visualization, the Venn diagram, or we can do the t-test, ANOVA test, as well as the PCA plot. If you want to do the class prediction, you want to create the model, you also can do from the MPP software. So it's more flexible for customer to choose what the statistical or chemometric that they want to do. For example, here, I'm using the PCA plot. In the PCA plot, I can see the group of the different sample of the apple. For this case, we can see that in each group can have the good classify, right, in different location. And we also have a lot of function of the filter that can be used to focus to you analyze. And I will provide some example of statistical test here. We have the full range of the t-test, right? And also the ANOVA test that customer can shoot. We have the multiple testing correction, for example, Bonferroni. This one will reduce the false positive and false negative for us. And we can shoot the flow change to see the difference between treated and control. So it's more convenient for you to choose the statistical test. And for the class prediction, MPP have the new function of the random forest and PDA and SIMCA as well. Those prediction models will support customer to do the classification, and software can support for clustering analysis. This one is unsupervised method to identify how closely of the relate metabolized. This one you can use the hierarchical k-mean or sales organizing map as well. That you can see that some group more related compared to another group. So on the right hand side, which will show you about heat map as well. MPP also have the correlation analysis. For correlation analysis here, we can see the difference of the compound by compound, right? On the right hand side, you can see that we can list the compound name and see the difference from the sample on the x-axis here. In addition, when we use the Venn diagram, in the Venn diagram, we can choose the unique metabolites. For example, here, for the Granny Smith apple GS here, you can see that we have 15 unique metabolites that found only Granny Smith, and they overlap around 614 compounds that's found in every apple. So the Venn diagram here, you can select the, in each region to do the identification. So for me, I will pick up the 15 compound here to do the identification because I would like to see the unique compound from the Granny Smith apple, for example. So in the detail, the MPP software also have the e-learning that we can start for the interactive how to do and study software step by step. So right now we already use the high resolution Qtop system to acquisition the data. Then we are using the provider software for batch analysis to alignment, to grouping the compound together. Then we send those compounds to MPP to compare the statistical testing to get only the really important compound. The next step, we will pick up the unique or maybe the important compound to do identification. And during identification, they also have the level for identification as well. For example, here, we will start from level 4 that we will not be unknown compound. We don't know anything about them, right? That one is really hard to identification. Level 3, we will identify according to the characteristic of them, maybe a chemical class of the compound. Level 2, we focus on the physical property of the compound. And level 1, right? The level 1 will check both reaction time and mass, or it can compare to authentic standard. That provide you more confidence for identification. In the identification process, right? We may need the database to do identification. If we have only the accurate math, it's not too confident, right? And when we increase isotope pattern, reaction time, MSMS, or MSMS library and reaction time, it will increase the confidence as well. So we also need the database that can support for identification process. For example, Medlin database, right now they have more than 100,000 compounds. And we also have additional software, for example, molecular structure correlator or serious software that can support us for MSMS structure confirmation. So in the workflow from Agilent, we also have some searching database software here. When we export the results that have 15 compound, we can search with database search here. We can choose the different database, right? We can choose the search by mass with retention time, and it will check the results and show the score for us. And it will show the best compound that match to the database as well. For example here, when we search only the accurate match and isotope ratio, if compound are good match, that means the mass spectrum view inside of the red block here, right? And on the below photo, you can see that some of the mass spectrum not match to the red block. That means the score will be low compared to the top one. However, if you get the same math, same accurate math, and have the ppm error at the same, how do you do to differentiate between two of them, right? That is really challenging for researcher. So we also need the tandem mass spectrometry to fragment the precursor to be the product ion. For example here, adenosine and deoxyguanosine. They have the same precursor mass. If we did not fragment them, it's really hard to differentiate between two of them. So during the tandem state, it will fragment to be the product ion here, and we can match to the database. So we can differentiate both of them. The next one is the example of the positive as well. In the positive mode here, we also see the difference of the product ions of adenosine and deoxyguanosine. So the important one is you need to create your own database, right? Because the database is really useful. You can use your standard to run the sample or to run the standard and create your own database. And to support that, we have the PCDR manager here. The PCDR manager will support for the user to manage the content in the personal database and library. This one have ability to add, remove, or edit compounds, as well as spectrum that can grouping some of the compound together that will focus to your experiment. And it will support both GCMS and LCMS platform. In another way, if you want to create the database from the pathway, for example, if you want to choose the Saccharomyces organism, you can choose the pathway to CTL software here. For example, I will choose the Saccharomyces cerevisiae, right? After that, I will choose the pathway that I want to see, and the database will summarize all of the compound in each pathway. That's more convenient for customer when they want to analyze and then send to pathway architect. Okay, here, after I choose the Saccharomyces, right, I can choose the two pathway here. After that, I can create the PCTL database for my study. After we match the database and the data, it will show the compound name here and the score as well. In the software, you can use the compare spectrum that will compare between your acquisition data and the database data in terms of the Miller plot. And after that, if you found that some of the compound not matched and you would like to search the bigger database, for example, ChemSpider, PubChem, right? You need to export the result. For example, here, I would like to identify mass 212 here that have fragment product ion shown in the red box. I can use the function of export to do the MSC software. The MSC software will automatically match your fragment to the ChemSpider, and it will ranking the putative compounds for you, and it will also show the score, and you can use this data for your identification. So the molecular structure correlator is really useful for unknown because it will correlate the MSMS fragment that we interested to the systematic bond breaking approach. For example, here, if this fragment match to the compound, it will show in the black color, right? And this one is breakout. So it's more convenient for a customer to find the candidate's molecular structure. The way to do, you can start from import the data, and then it will run through the ChemSpider, and it will show the fragment mass and the mesh structure. I will show some example here. I will create the new project that I will include more than one export file. And after that, it will load around 31 spectrum, right? And it show the positive mode as well. In the setting, you can choose the difference of the element hydrogen, carbon, nitrogen, and oxygen. Or if you want to add the chlorine, you also can add click at bottom here and choose the chlorine, and it will show up in the molecular formula generator MFG here. So when you click search, it will support you to search again, maybe ChemSpider, or maybe from your Mo files or your Medlin database as well. After that, you can save the current setting. And the system will automatically identify the compound and the formula for you. That's really useful for identification. So in the MSC review, you also can see the different of the function that you can see the different collision energy that when you fragment the compound that can support you for identifies. For example, here I have amino carb, right? The amino carb here we have at least 4 fragments. In each fragment, we show the highest score, right? That means this mass fragment here and fragment here, and provides the 137 mass for us. Next one is the summarize of the MSC software that will show you about the putative of the results. In the result here, they have a lot of the score that you can use. For example, the penalty score and math accuracy score. we will use both of them to analyze and choose which one is the best for your identification. So the MSC can be used to support us to identify the proposed structure and support for identification the true unknown, right? But it cannot identify the true unknown because it's also it's like it's narrow down the possibility for user to get the idea of the structure of the compound. So the MSC support on that. Okay, right now we already use the QTOF system. We use the profiler for batch analysis and use the MPP to do the statistical testing before we identify them, right? After we identify the compound, we can send this data to pathway analysis. For pathway analysis, we may link between metabolized protein as well as the genes. For the Agilent, we have the Agilent Bridge database because sometimes the compound name in each pathway may not be the same. For example, if we have the compound list as dextrose, it should be D-glucose in the pathway. So we need to resolve the mapping problem between database. In pathway architect, for example, here we can choose the list of pathway, right? We can use the filter of the minimum that we want to see, and this will show you the pathway viewer as well as the data value as well. So in pathway architect, you may start from choose the organism, and after that choose the pathway that you want to see. For example, here is the wiki pathway that you can choose a bioscience, for example. After that, when you continue identify and using pathway architect, you can get the pathway results. For example, here that will show you in the color and the abundance of the compound. In addition, pathway architect here can link between the metabolomics and metabolomic, or metabolomic together with proteomic as well. Just expand your research, not just the metabolomics. If you have some data from proteomic side, you can put together and identify. So we start from here, from data acquisition, right? And we would like to get the pathway visualization. That is the idea for your metabolomic research. I would like to summary here for the Agilent metabolomic workflow. We start from the QTOF system for separation and detection. After that, we go to the profiler software for file filter. We do the statistical testing using MPP and identify using ID browser. We also can build the model from MPP to create the classifier, or we can use identify the compound for pathway architect. If we have target of your metabolomics, we can use the triple quad system for target detection. I have some example here for metabolomic research. In this study, they would like to see the profile of the metabolites in T, right? Because metabolite approach can apply for non-volatile compound in different subtype of white tea. This one would like to elucidate the characteristic of metabolites in different trees. We start from sample preparation. We do the separation technique QTOF system together with the data analysis software. In application note, they recommend how to set up the LC system and how to set up the QTOF system as well. That will speed up the laboratory. After that, when we get the results from the LCMS, right, we send to the MPP chemometric software to identify the interested compound. From these results, we can use the PCA plot, differentiate 3 types of the white tree, start from silver needle, white peony, or sumai. After you get the model, right, that differentiated between 3 of the white tea, you can build the model and you can check the accuracy of your prediction. If the accuracy is 100 score, that means your model is really nice. And you can use this model for classification sample. And we can use the database to identify the metabolites in the tea as well. For example, here we identify up to 99 compounds that we would like to know about identification. And we can show about hierarchical analysis to see that in different of the compound that have different of the testing, those information really useful for research. Next one is plant-based alternative protein. Right now, a lot of customers, they choose the plant-based protein. And how do we make sure that the plant-based protein or alternative protein have similar or have significant similar to the real meat, real protein, right? So we need to check about taste, textile, and composition as well. But if you use your sensory testing, is quite subjective. We cannot know that different person may have different taste, right? So we use QTOF system. We analyze the plant-based chicken, plant-based beef, and plant-based pork. After that, we will align the results. You can see that on the right-hand side on the PCA plot, the chicken, beef, and pork look like they are very close, right? That means the manufacturer, they do a good job because the chicken is really close to the plant chicken. But when we look closer in the detail, you can see that the real meat chicken and plant-based chicken 1 and plant-based chicken 2 also have some different, right? And when we identify the compound, you can see that the chicken have some unique compound compared to the plant-based chicken, especially for hypoxanthine here. The hypoxanthine here provide the umami taste. So it looks like chicken is more delicious. However, the hypoxanthine relate to uric acid. So some person may not want to taste the hypoxanthine. The plant-based chicken may be a good choice, right, for them, maybe for the more healthy compared to the real meat. But they also have some the compound that provide umami taste as well. So this information is really useful for manufacturer to improve about their production. Next one show the heat map of the beef and plant-based beef. When we take a look on the amino acid here, you can see that some of amino acid here show the bitter taste. For beef, have low L-arginine. That means it's less bitter. So that means the real beef should be more delicious compared to the plant-based. So this information also important for a manufacturer to develop about their plant-based. So the fabulous texture and nutrition in alternative protein are really critical for consumer, right? For the acceptability or the value, right? So using the non-target data dependent system from the QTOP can have the good profiles and identifies the compound, and manufacturer can develop about their production for get better taste as well. The next one, this study would like to discover the potential marker compound from star white tea. In this example, they have the different year of starlet tea, and you can see that we can differentiate the 1 year, 2 or 4 year, or more than 4 year, very clear. When we know that some compound can be a good marker, we can identify them. And you can see that those compounds here change after 4 years. So those compounds here may be good candidate for a marker to check about the storage time. And you can use MPP software to identify the compound as well. And the result here, we show the correlation between the storage time of the ESPF group compound. Next one is using the QTOP system for classification, right? I will start from the difference of the mango puree purity. We have recommend how to do the sample extraction using the cashier extraction, and how to set up the LCMS, as well as how to choose the column system. From this study, I have the 3 types of mango, and I have 6 biological replicates. I have the QC and otherless QC as well. After the cashier extraction, I will send to the QTOP system. From the QTOP system, and we using the MPP to create the model, we can have the classifier 3 mango out, right? And if you have the sample, for example, here is mixing between 20% and 80% of the mango, it will show the result in between, right? If you have 80% of the green one, that means it may be close to the green area here. So we can use a lot of the function for your analysis. In summary, I would like to say that the metabolomic workflow, we need to start from how to prepare your sample in the appropriate way, right? If you do not prepare the sample, we may get something that's not important for us. So the sample preparation will affect about the successful of the results. And I always recommend to use the QC to evaluate the instrument and sample preparation reproducibility as well. Please take a look on your data to determine the noise threshold that we need to set up. After that, if we did not set the correct threshold, it will affect for your data analysis. Finally, for identification, we need to consider to have the database and how to annotate the compound. And after that, we can send the identified compound to do the pathway architect to get the final results from the metabolomic study. Okay, that's all of my slide. Do you have any question?
Yes, okay, Thanong. Thank you for your great presentation. Ya, bagi Bapak Ibu silakan yang ingin mengajukan pertanyaan bisa mengajukan lewat kolom Q&A di bawah atau kolom chat di bawah. Silakan. Ya, mungkin apabila Bapak Ibu ingin bertanya langsung, silakan boleh membuka mic-nya atau open mic-nya silakan. Nanti akan dijawab langsung oleh pemateri kita pada kesempatan kali ini. Mungkin sedikit saya ulas ya yang tadi disampaikan. Untuk trigger Bapak Ibu kiranya nanti mungkin ada yang akan ditanyakan dari kesimpulan yang sudah disampaikan oleh pemateri kita saat ini. Yang pertama mungkin untuk persiapan sampel yang baik dan yang dapat direproduksi akan memberikan hasil yang sukses. Kemudian juga tadi disebutkan selalu menggunakan QC untuk mengevaluasi reproducibility instrumen dan persiapan sampel atau preparasi sampel. Kemudian perlu diperhatikan juga untuk mempertimbangkan tingkat identifikasi saat membuat anotasi dan mengidentifikasi senyawa. Dan juga tadi disampaikan untuk analisa metabolomik ini sangat membantu sekali dengan menggunakan Agilent LCMS MS QTOF ya, ketika dipadukan dengan software MPP dan menggunakan chemometrik. Kurang lebih seperti itu. Silakan bagi Bapak Ibu yang ingin mengajukan pertanyaan.
Saya mau izin bertanya, boleh?
Iya, silakan Ibu.
Ya,
Silakan memperkenalkan diri, Ibu siapa, dari mana, silakan untuk bertanya langsung kepada pemateri kita.
mungkin saya bahasa Indonesia aja nggak apa-apa ya Mas ya? Nanti dari Indonesia saja, boleh?
Iya, boleh.
Nah, tadi terkaitan ada QC tadi, terkait QC yang akan dianalisis itu sebenarnya QC seperti apa yang kalau kita punya banyak sampel, QC seperti apa yang harus dianalisis. Kemudian tadi pertanyaan yang kedua, tadi kalau nggak salah dalam skema analisis metabolomik tadi ada membangun model gitu ya Mas ya. Kalau nggak salah sebelum kita melakukan target analisis. Nah, apakah dari software tersebut sudah ada informasi terkait tadi senyawa target yang akan dianalisis dan bagaimana sih maksudnya prinsip pembangunan model yang ada di software tersebut? Gitu.
Jadi dua pertanyaan ya Ibu. Yang pertama
Ya,
ada QC seperti apa yang harus dianalisis kalau banyak sampel begitu. Yang kedua, apakah dari software MPP tersebut ada senyawa target yang akan dianalisis?
Iya.
Oke. Ya, Thanong, we have one question from Ibu Dewi. The question is, what kind of QC should be analyzed if there are many samples? Yeah, please answer.
Let me confirm the question. How to set up the QC in the long of the analysis, right? If you have a lot of injection, a lot of sample, right?
Yeah, a lot of sample.
Yes, actually, right now we have the function. I mean, because we need to run the QC in between of the sample. It's something like randomly. It's not just put the QC in the first sequence and run the sample for the rest. It cannot be do like that. I mean, QC sample should be randomized in between your sample, right? If you have a 100 injection, the QC sample should be randomized between your sample to make sure that from the first injection until the 100 injection, all of the system in a good condition. And right now, the Agilent software have the function that will automatically random for user. Something like when you put 10 QC sample, it will automatic random in the whole sequence for you. Did I answer the question?
Okay, thank you. Thanong. For second question is, does the MPP software contain target compound that will be analyzed?
Target confirm. For the target quantitation, right? Actually, if they want to do the target analysis, we can use the Metenter quantitation. That's more convenient for quantitation analysis. No need for MPP.
Oke. Bagaimana Ibu Dewi? Thank you, Thanong, for the answer. Next, silakan Ibu Bapak bagi yang ingin bertanya kembali. Mungkin ingin bertanya langsung atau silakan untuk menuliskan pertanyaannya di kolom chat. Okay, Thanong.
Yes.
Another question from Ibu Lydia. The question is, can you share about metabolic profiling of natural product, especially plant extract? The aim is to identify what compound are contained in the extract.
We have application notes to provide you some example of natural product as well. Let me prepare that for you, and maybe need your support to send to Linja. Yep, we have the application note on that. Can we share after the meeting?
Oh, sure. Okay. Silakan bagi peserta yang ingin mengajukan pertanyaan, mungkin pertanyaan terakhir sebelum sesi ditutup. Ya, last question for Ibu atau Bapak Supiani dari Bidlab for Sumut. The question, what's the problem in interpreting the result? Yeah.
What the
Thanong.
problem? What the problem? Can
For
you repeat?
interpreting.
I would like to say that. Can I say what is the challenge for data interpretation?
Yeah, challenge
Yep.
for interpreting data or result.
Yes. The challenge for data analysis comes from a lot of the compound, right? From one injection that you get from the QTOP system. when one data file, you may get 1,000 compound. How do you compare 1,000 compound from 100 injection? So this issue is really challenging to align compound together, because when you report the metabolomic results, you need to show the significant compound to make sure that this compound represent to the population, represent to the whole sample. So the issue come from a lot of the data. You may get 1,000, 10,000 compound that to analyze. So that's why I talk a lot on the software application, because the software will support user to reduce the complexity to handle the data.
Ya, clear. Next, mungkin silakan Bapak Ibu. Sebetulnya masih ada waktu panjang ya, 15 menit lagi. Mungkin ada yang masih penasaran atau yang ingin ditanyakan. Kiranya Bapak Ibu ingin menanyakan terkait instrumen yang sebelumnya sudah dijelaskan boleh, ataupun mungkin terkait Metabolomics-nya sendiri boleh, silahkan. Ya, kita tunggu sebentar. Ya. Oke, mungkin tidak ada yang bertanya lagi dari Bapak Ibu peserta. Terima kasih Bapak Ibu peserta atas antusiasmenya. Thank you Thanong for the answer. Very interesting what was your present. I think it's enough that no one else. Ya, terima kasih Thanong untuk pemaparan materinya. Terima kasih juga Bapak Ibu sekalian atas antusiasmenya, yang mudah-mudahan ke depannya ini kuliah metabolomik ini berlanjut ya. Oke, sekian dari saya. Mohon maaf apabila ada yang kurang berkenan dalam penyampaian materi ataupun mengantarkan pemateri pada kesempatan kali ini. Terima kasih atas antusiasmenya. Saya kembalikan lagi ke moderator. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Baik, terima kasih Mas Fahmi selaku moderator pada kegiatan kali ini. Baik, kita sampai ke penghujung acara ya. Terima kasih. Once again, thank you very much for your sharing, Mr. Thanong. Your presentation is very informative, and hopefully we can applicate in our place. Oke, Bapak Ibu sekalian, sekali lagi kami dari segenap panitia, saya Layang Sari selaku MC, mohon maaf bila ada hal-hal, kata-kata ataupun perilaku yang belum berkenan. Kami tunggu Bapak Ibu sekalian pada kegiatan-kegiatan kuliah umum metabolomik lainnya. Sampai jumpa di lain kesempatan. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Ya, terima kasih.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih.
Thank you.
Ya, thank you Thanong.
Assalamualaikum.